All right, so let's continue with the discussion on linear acceleration down the ramp. Now, if you apply the Newton's second law, you can see the equation number 1 has been applied. Now, the second equation is about the torque. Okay, since there is a rolling involved, we had to introduce torque. So, frictional force multiplied by the radius, which is a force arm, tells us the amount of torque generated by this frictional force, and it is equal to I into alpha, where alpha is the angular acceleration. So you had one, equation number 1, which is Newton's second law, and the second equation is the one that deals with the torque. Now you can substitute the value of friction in the equation number 1, and you can see at the bottom you will see the substitution where the value of friction has been inserted in the Newton's second law. And with the help of this, you can find alpha, which is the angular acceleration of this round body, which is coming down the plane. Once and before you proceed towards alpha, you must remember that this is a case of pure rolling. The linear acceleration, through the center of mass or off the center of mass, will be given by radius into alpha. So find alpha and then finally find a center of mass using the formula R alpha. Thank you.